Good morning. This is Kasturi Day. Today, I'm going to again discuss the element compound mixture chapter. In my last video, I discussed about the process. The purpose of separating the components of the mixture. And then I have also discussed the how to separate the solid mixtures. Okay, now we have come to discuss today the separation process of solid liquid mixtures. So first we have come to the first process, that is sedimentation and decantation. Here see here the solid and the liquid are heterogeneous mixtures. In the mixture, the components of the solid and the liquid, that is the components which are present in the mixture, heterogeneous mixture, those two are heterogeneous mixtures, and that is the solid does not dissolve, is insoluble in the liquid component, and the solid component is heavier than the liquid component. For example, say mixture of sand and water. See here what happens when the sand mixture, that is sand and water, when it is mixed, and if we keep the mixture for some time, we will see that the sand will settle down at the bottom. Okay, that as a sediment, and that process is sedimentation. Okay, so sand is settling down at the bottom of the container, that is here it's a beaker, so that is a sediment. So we can separate the sand, the sediment, from the water which will float over the sand as a supernatant liquid. Okay, and that we can slowly pour into another beaker. Okay, slowly pour that into another beaker, and that excuse me, that will be the process of decantation. Okay, now this is the process how we can separate the heavier component of the solid from a lighter component of the liquid. Now filtration is a process. Next process is filtration. So here the process is also the heterogeneous mixture. That will be a heterogeneous mixture where the solid will not dissolve in the liquid. Okay, here the substance, substance is used, that is known as a substance that will filter out this solid insoluble substance from the liquid substance. Okay, so for example, the filter paper, charcoal, glass wool, layers of sand, that are all used for as a filter. Okay, for filtering this solid from the liquid. Now here in this picture, you can see there's a filter paper which is used in a funnel. It is attached to a funnel, and the solution, the mixture is not solution, the mixture is poured inside through this funnel. Okay, now the solid mixture, which is the solid, the component that is insoluble in water, in the liquid component, that will get collected in the filter paper inside the funnel. Okay, that will be the residue. Okay, and the water or rather the liquid will flow through this filter paper into and collect in another conical flask. Okay, and that will be conical flask. Okay, so that will be the filtrate. Okay, that will be called the filtrate. Okay, and this is how this filtration process is done. Next we come to the evaporation process. Here what happens, the solid liquid mixture will be a homogeneous mixture, where that is the solid will completely dissolve in the liquid. By this process, we can extract the solid by evaporating the liquid in the form of vapor. For example, we can extract salt from seawater by this simple process of evaporation. Again, we can do by crystallization. One other process is crystallization. Here also homogeneous mixture is required. Homogeneous mixture is used for it can be the components of the homogeneous mixture can be separated by crystallization. What happens in this process, that the solution, where the solute is completely dissolved in the liquid, that type of solution will be heated. Okay, now one thing you know, that when a solute dissolves in a liquid, at room temperature, the amount of solute which is getting dissolved in the liquid at room temperature, this amount will be increased. I mean, more of solute will be getting dissolved in the same liquid at higher temperature. If the temperature is increased, okay, the solubility of the solute gets increased with the rise in temperature. Okay. So what we will do, we will heat the mixture, okay, and we will see that more of the solute will be getting dissolved in the solvent. Okay. Now, as we are heating the mixture, the solvent will get evaporated. Okay. Now, and one time it will come that the more of solute will not get dissolved in the solvent. Okay, that time we will stop heating and we will start cooling down the mixture. And when we are cooling down the mixture, we will see that the solute particles will separate out from the mixture in the form of crystals. That's why this process is known as crystallization. Okay. So for example, see extraction of pure sugar. So pure sugar can be extracted in this way. Okay. See the picture, you can see the crystals. First we are dissolving the solute, okay, in this mixture. Now we are heating it, more of solute will be getting dissolved. Then we are cooling it, see crystallizing out, the solid is crystallizing out. See, this is if liquid evaporates, the more of crystals will be coming out from the mixture. Okay. Next is distillation process. So in this distillation process, here also the solid liquid mixture is used, in which both the solid will totally get dissolved in the liquid. Here in this process, we can get back the liquid as well as the solid both. In the previous mixture, the first two process, evaporation and crystallization, the liquid gets evaporated. We will not get back the liquid, only the solid we are getting back, but we are separating the two. But in the distillation process, what we are seeing that the solid liquid mixture, both we are getting back the solid as well as the liquid. The solid, when we are heating the mixture in a distillating flask, okay, see another tube is attached to this. This is known as Liebig condenser. Okay, this tube is known as Liebig condenser. There's a tube through which the liquid after evaporating will pass through, and at the time when it is passing through this tube, it will get cooled due to the cold water which is flowing through surrounding this tube. Okay, so this is known as Liebig condenser, through which the the liquid which is passing through this tube after evaporating will get cooled, and it will get condensed in a liquid form and will get collected as a distillate in another flask. Okay. Now, after this liquid evaporates, the solid will be left behind as a residue inside this distillating flask. Okay. So this is how we can separate the solid and the liquid. Okay, for example, say tap water is separated from its dissolved salt. Whatever salts which is dissolved in the tap water, we can separate this dissolved from salts from the tap water, or you can separate a mixture of iodine and alcohol by this process. Okay, next is we come to centrifugation. Now the centrifugation is a process. Here also the solid liquid mixture, these are homogeneous mixture. Here one apparatus is used known as a centrifuge. Okay, a centrifuge tube is also used, in which this mixture is poured, and this centrifuge machine, that apparatus, that will rotate this centrifuge tube inside it, and it will separate out the heavier solid particles down, and this lighter liquid particles will float inside the tube. Okay, and this is how we can separate the solid liquid mixture, homogeneous mixture. For example, see, we can separate the cream from the milk, or we can see, we can also separate the components of the blood or components of the urine, which is present in the, this is generally used in testing of the blood and urine in the laboratories. Okay, so this is the centrifuge tube. I mean, this is the tube and this is the machine in which the tube is placed and it will rotate. So see, this is the blood component, which has been blood mixture, which has been filled in this tube, and it is placed inside the tube, and this will rotate in this way. And the plasma has been separated from the blood component, blood cells. Okay. Next, we come to the liquid-liquid mixture. Okay. So by this process, first process of this separation, the liquid-liquid mixture is using a separating funnel. Now the separating funnel is a funnel in which there is a stopcock attached to it, and there's a beaker which is placed just below the separating tube funnel. And if we place the liquid liquid mixture in the funnel, we will see after some time, we should give a standing time to it, where the liquids will be separating according to their different densities. Okay, the lighter one will be floating above the heavier one. Okay. For example, see, kerosene oil and water or carbon tetrachloride and water can be separated by this mixture. Now, the liquid which is settled down inside the separating funnel, that can be separated, that can be extracted out from the separating funnel by opening the stopcock first, and then the one which is lighter, which is above in the funnel. Okay, so by this process, we can separate the liquid-liquid, immiscible liquids. See, this is also a heterogeneous mixture. Immiscible liquids mixture can be separated by this process. Next, we come to the fractional distillation. Here, the liquid-liquid mixture is a homogeneous mixture. That is, you cannot differentiate the liquids. Okay, here, the principle which is used is the boiling point difference. Okay, the liquid mixture, the liquids which are the components of this mixture, that will have different, those will have different boiling points. For example, see, water and alcohol mixture. Water has a boiling point of 100 degrees centigrade and alcohol is a boiling point of 78 degrees centigrade. So this can be separated by this fractional distillation process. Even the petroleum oil, the contents of the petroleum oil, that is petrol, kerosene, diesel, etc., that can also be obtained from the crude petroleum oil by this process. For example, see, the process is, see, this is the distillation flask where we put the mixture and it is boiled. Okay, there's a fractionating column there, and there's a thermometer attached to it. This is the Liebig condenser which is attached to it. Now what happens when the temperature rises to about 78 degrees centigrade first, in case of water and alcohol, first the boiling point of alcohol, the alcohol becomes vapor. It rises up. The water will not rise up so much, okay, because its boiling point is 100 degrees centigrade. The temperature has not risen up to 100 degrees centigrade. It has risen up to 78 degrees centigrade. So alcohol will become vapor, come through this tube, through this Liebig condenser. When it is passing through, it will get condensed and will be collected in a flask. Okay, the flask is removed. Then when the temperature rises to 100 degrees centigrade, what will happen? The water will get evaporated. It will come back as condensed. It will come through this and get condensed into water again, and it will be collected in a flask again and will be separated from the alcohol mixture. Okay. So this is the process how this fractional distillation takes place. Okay. So I think I'll stop here. I'll continue with the rest of the chapter in my next video. Go through this. If you have any doubt, please do write in the comment box. Do share with your friends and colleagues, and do also subscribe to get the notification of my next video. Thank you. Thank you for watching and have a good day.